Hello people, welcome one and all to Jojo's Learning Club.
Hello everyone, I'm back again. So today my topic would be on decimals. So the decimal numbers are based on the digits 0 to 9. So they are based on the digits 0 to 9. So let me write an example for decimals for your better understanding. 51.25. So the decimal point separating the number from the fraction, this is how you represent a decimal fraction. A decimal fraction is nothing but a representation of decimal and a fraction. So in this you have a number plus a fractional part. Sorry, this is a decimal fraction. So the decimal point is this. So this is how you represent a decimal fraction. So there are two kinds of decimal representation, that is a terminating decimal and a non-terminating decimal. Numbers which can be exactly expressed as a decimal fraction is called terminating decimal. Let's write an example for terminating decimal. 2 by 4, which is nothing but 1 by 2, and 0.5. You can see that after the decimal point the fraction stops, and that's why we represent it as a terminating decimal. Now let's take an example of a non-terminating decimal. So non-terminating decimal is a decimal in which numbers cannot be exactly represented. So for example, let's take the example of 4 by 3. If you take, you can see that 1.333333, it goes on, or the relation of pi, again 3.14, it goes on. So they are recurring, or so in this you can say that it is recurring, or they are non-terminating, because after the decimal the calculation goes on and that doesn't terminates. So these are the examples of non-terminating decimals. And also for non-terminating decimals you can represent it in terms of two categories. It can be made according to the accuracy which you require for your product or for anything. So for non-terminating decimals you can classify into two categories. They are now in terms of number of significant figures and in terms of number of decimal numbers. So let's write another decimal fraction. 32.76183. So we need up to number of significant figures. When you want to round up to number of significant figures, so we need up to 5 significant figures. 5 significant figures. So you have to always start calculating for significant figures from the left side, 1 2 3 4 5. And when you round up so this is the last, right? So when you round up you have to be always careful. You have to check the next number. If this value is between 0 to 4, then you don't make any change for the last number of the significant figure. If the value is between 5:9, then you change the last value of the significant figure with a +1 with it. For example, in this example, you can write it as up to 32.762 as 5 significant figures. Or for another example, 32.76143. In this example, the last digit of significant figure, the next digit of it is 4, which is in the ratio, which is in the group 0 to 4. So we don't make any change. So I will write it here. So no changes. In terms of this, +1 is added to the last digit of significant figures. So in this example, up to 5 significant figures, how you round it up? 32.761 itself. So this is how you represent significant figures. And let's represent this in terms of 4 decimal numbers. So when we have 4 decimal numbers, you don't have to round up anything. You just have to write up to 4 decimal places. So 7618. And if it is said up to 2 decimal places, the answer would be 32.76. So up to 2, here up to 4 decimal numbers. So this is how you do rounding up with decimals, and this is what all about decimals is. Now let's do some exercise to get a better understanding on decimals.